Well, thank you everybody for joining this presentation on the McDonaldization of IT, loose coupling design. Now, exactly what am I talking about? In my area of development, a lot of times I've been working with multiple different technologies, as you've heard, and it really requires a level of redundancy that's built in, and then also a bit of interconnectedness with your systems as well. And that's where loose coupling design comes into play. How can you design your application so that each individual piece is encapsulated on its own? And does it ever, if it ever does fail, or if anything does fail in regard to that specific service, how can you come back up quickly from that? Now, what does this have to do with McDonald's? I saw this on one episode of some kind of fast food website on a cooking channel. And back in the 1940s, the owners of the then McDonald's, they had a problem, which they've been running a restaurant for the past 11 years. And for those 11 years, they've had to compete with other restaurants, not only in quality food, but also in hiring their specialized employees, most notably their short order cooks. So as you can tell, that short order cooks were then in high demand and really kind of held the business back because of the constant struggles the owners had to deal with to either keep their highly skilled workers employed or attempting to find additional ones to replace them. And it wasn't something that you could just easily learn overnight. You had to go ahead, and they had trade schools essentially that were designed to teach people these skills that were required to cook a high variety of foods relatively quickly. So these owners just had too much time that they were wasting on solving their employment problems instead of actually increasing or solving their business problems. They ended up shutting down their business for a few months to rethink their initial strategy. So they really wanted to simplify their business to the point where they could have anybody off the street come in and take over some individual piece on their assembly line, essentially. So they ended up breaking their food preparation down into single tasks. They had an assembly line-like process that the short order cook was previously responsible for, and each person just had charge of their own task, whether it was flipping the burgers or adding condiments, et cetera, et cetera. And this is how they actually isolated their tasks. They were able to then take this one person that was managing these multiple processes and take it down to where multiple people could work on one thing really, really well and add that to the entire assembly line. And that overall increased how fast food was made, and not only then, but how quickly it was made at that point too. And then they also had to rethink their kitchen as well. And you can kind of use this analogy with hardware inside of IT. You can't just take your old process or your old hardware and kind of refabricate it all the time for your individual processes. Sometimes you do require some specialized hardware in order to really take advantage of all these new ideas that you're building onto. Now, some considerations that you'll have to take in application design, you'll have to know exactly how you're going to load balance your execution. So if you happen to be asking for resources for your specific database, you need to figure out, okay, how am I going to route my logic? Am I going to have a load balancer? Am I going to have some type of middleware which ends up taking the request and then puts it out to whatever server needs to answer it? Your hardware, you definitely need more hardware so that you can actually have a level of redundancy. And this comes into play with load balancing as well. If you have a database that's replicated and you have access to that replicated read-only database, you can sort of load balance your reads to both of the databases, so one doesn't get overloaded or overwhelmed because it's accepting reads and writes. You do have to understand that with adding additional hardware and scaling up your application, obviously network traffic is going to come into play, where sometimes you're going to have all these machines that are trying to communicate with one another, and they're going to just ask for way too much information and really hog up whatever bandwidth you have. So be conscious of what you're asking for. Be conscious of how you're actually scheduling your requests and go from there. I mean, it's not something that you can always predict, but you could use some clever ways to isolate your requests on your network if that is ever needed. And then also think about denormalizing your data. There are often times when a SQL join can really affect your database performance, and you should really think about whether you do need that linking table or not. There's times when you can take, say, like you have a customer and they have a linking table of phone numbers. Well, it's great that they can add an unlimited set of phone numbers, but how likely is that ever to happen? So split that out, have them have their own individual, like 4 phone numbers inside of their individual customer record. There's really no problem to having that except for maybe some nulls inside of some empty values inside of your database, but it does completely eliminate that join. And if that is the case of if that's your area of performance integration, then definitely look into that situation. Now, as everybody I'm sure has heard, another reason that, well, big data is just, for lack of a better term, it's huge inside of marketing now. Everybody uses this term. What people don't really realize is that volume isn't just the only answer. And big data has really become synonymous with analysis now. It's just not the size of your data. And really, how can we make that a little bit easier to work with inside of loose coupling, especially when you have all these different types of data that are being integrated and connected, or attempting to be connected. Because it is a difficult challenge that people face to bring all this data together and make sense of it. And then also you have to add on top of that data changes over time, and you have to think about how exactly do you want to manage this. Do you want to hold time slices of, say, for example, retweets in a Facebook post? Like you happen to see that your Twitter account had 5 retweets on one specific post at 11:14 on October 8th, or do you just want the overall, the end goal of what it is when it's finally done changing, or a combination of the two? So think about how you want to use it. Think about how you're going to deal with the volume. And then, like I touched on a little bit in the previous slide, the variety